Hi, everyone, and welcome to today's talk, Computing at the Edge, Choosing the Best Option for Your Application. I'm Charlie Hamill, Principal Enterprise Architect with AWS. What is edge computing? Well, for today, I'm going to suggest that it's these three things. It's about where your services run, how your services run, in order to reduce latency. So where your services run. You may have a piece of agricultural equipment running out in a field and it's emitting important telemetry that you need to get. How does it get there? Where does it go? Where does that service endpoint need to be? Or then there's the other extreme, which is a complex factory with a lot of things going on. And you're pretty sure the endpoint needs to be really close, like maybe in the factory. And then how your services run. The traditional microservice stack is stateless, and all state lives in a database. So it involves checkpoints to the database, lookups to the database. And in order to scale that endpoint, that microservice should be in perhaps many data centers, and so does the data. That can add milliseconds to your request time. The newer stateful microservice keeps all state in the microservice and maybe checkpoints it to a database, which can eliminate many microseconds from the request. So that may be an option for speeding up latency. So we said it's all about in order to reduce latency. And what are IoT industrial customers doing with AWS? Well, we see customers doing a lot in factories to improve the performance of productivity and industrial processes, remotely monitoring patient health and wellness applications, tracking inventory levels and managing warehouse operations, and much more. And then in Industry 4.0, which is Industry 3.0 with a lot of intelligence added to it, we see customers adding big data and machine learning analytics to their premises, augmented reality, cloud capabilities, additive manufacturing, all integrated with offline capabilities, either in the cloud or in a data center somewhere. And they also want to leverage skills and resources that they already have and not have to think of entirely new application development approaches. And here's a particular Industry 4.0 e-commerce company with a lot of robotics and artificial intelligence and automation involved. And many of you probably use this company every day. So to move forward, let's answer these three questions. Your field devices and applications need services. You need low latency, and the cloud may not be close enough. And this is really hard to do yourself. Let's take a look at the AWS Edge to Cloud continuum. Starting at the far left, on site or in the vehicles, you may have microcontroller-based devices, and they need to run an operating system. That could be free RTOS. Moving a little bit to the right, you have CPU-based devices, and they can run something called AWS IoT Greengrass, which can be the hub of all your communications. And then at the bottom, we have machine learning at the edge with models developed under Amazon SageMaker, or robots with software applications deployed on them using Robomaker. And then above that, we have AWS IoT SiteWise, which is a way of connecting to all of your legacy equipment in a factory for communications purposes. And then we have AWS Snowball Edge, which is a compute environment that you can install in rugged environments like transportation, shipping, or harsh retail environments. And then moving further, we have the public mobile infrastructure with AWS Wavelength running in 5G telecommunications providers. And AWS Outposts, which is bringing a piece of AWS availability zones right onto your on-premise facility. And then going all the way over, we have the AWS Cloud, which is a region with multiple availability zones, and today, even points of presence in a local zone that's outside of the region and close to a big urban center to get things even closer. Let's drill down to another level. So here are your field assets on the far left, PLCs, SCADA, or historians. And we can layer in industrial gateways from our hardware partners to the field. These are running key AWS IoT edge services like IoT Greengrass and IoT Sitewise Collector. And they may be running protocol converters from an AWS partner like Kepware to convert your industrial protocols to MQTT or OPC UA, which can be consumed by IoT Greengrass and IoT Sitewise Collector to push up to the AWS cloud. And this data is ingested into our cloud via IoT Core or directly into the IoT Sitewise operational dashboard, giving you an initial look at your near real-time data. You can also do complex condition monitoring of this data streams with IoT events. And if you like what you see after all this data arrives, you can start collecting it in a data lake and doing analytics on it using our BI tool, AWS QuickSight. And so far, you've just done basic data monitoring and visualization. You may now be ready for heavier analytics using Amazon Athena for ad hoc querying and Amazon SageMaker for building ML models. And this is where the real business problem solving begins. ML models can be built for a wide range of classic or custom use cases, such as product quality improvement on one end or predictive maintenance on the other. And for a little story here, Volkswagen builds their industrial cloud on AWS with a goal to improve production efficiency by 30%. They face the challenge of generating insights into and enabling improvements of production processes based on the combined data ingested from all VW plants. And then they also needed to scale solutions such as a digital shop floor management solution in production across plants based on a standard platform. So they started by connecting the shop floor through IoT Core and AWS platform services to a central data catalog using AI and ML for the heavy lifting and well-architected security standards for the enterprise cloud. And then they also drove and scaled platform capabilities through a set of microservices that can be swiftly adopted by VW business communities rather than on a per use case basis. And the results are they've onboarded entire plants already using available solution standards that enable the VW builder community at large. And then core assets they have in the form of microservices and blueprints that allow the VW business to quickly deploy ready-made solutions on the digital production platform. So let's take a deep dive into the product portfolio of AWS IoT and edge computing. We're going to look at 4 categories: device and edge services, connectivity and control services, analytics services, AI and ML, all wrapped in integrated security. So let's zero in on device and edge services first. The portfolio includes AWS IoT Greengrass, FreeRTOS, IoT Device Sdk, IoT Device Tester, Robomaker, Snowball Edge, Storage Gateway, Outposts, and Wavelength. So with Greengrass, you embed local Lambda compute and local messaging and device shadows for data and state synchronization, as well as security of communication and to connected devices. And this is effectively a software runtime that embeds in devices, and it allows you to have Lambda inside those devices so you have the flexibility in the compute and events that trigger it. And today we enhance the capability of Greengrass even further with 3 capabilities. One of them, OTA, which makes it easier to install updated versions of Greengrass Core. And secondly, OPC UA, which is a popular industrial messaging protocol that's widely used in manufacturing, logistics, and other heavy industrial contexts. Customers such as Sony want to use Greengrass to process data in existing facilities whose equipment already communicated using OPC UA. And then there's LRA, the local resource access, that lets Greengrass Lambda functions interact with the hardware capabilities of the device that hosts the core. Local resources can be physical devices, peripherals, and hardware components such as cameras, serial bus, hardware accelerators, or storage volumes in the local file system. And last but not least, Greengrass ML inference brings machine learning to the edge. Pentair is a global provider of water filtration systems equipped with sensors to breweries, fish farms, and other industrial commercial customers. These customers have adopted membrane filtration technology in lieu of using chemicals at production facilities. Pentair wanted to improve beer membrane filtration processes with higher predictability for customers. Pentair runs its beer membrane filtration system on AWS IoT. They developed a cloud gateway on-premise at production facilities. AWS IoT Greengrass runs Lambda functions inside to extract membrane performance and information to securely transmit the data using IoT Core to process the data from those remote facilities. And as a result, Pentair can increase predictability with regards to planning for brewers and boost beer filtration system performance by 10% at lower costs. Now, FreeRTOS includes the FreeRTOS kernel, the market-leading real-time operating system for microcontrollers. And we're very honored that Richard Barry, who invented FreeRTOS 15 years ago, has joined AWS as the principal engineer working on FreeRTOS. FreeRTOS includes the FreeRTOS kernel and software libraries that make it easy to securely connect your small, low-power devices to more powerful edge devices and gateways running AWS Greengrass or to AWS cloud services like AWS IoT Core. It provides everything you need to easily program connected microcontroller-based devices, collect data from them, to send to AWS IoT for analysis and action, and scale IoT applications across millions of devices. FreeRTOS provides convenient APIs that make it easy to connect to AWS Greengrass devices. If the Greengrass core device loses connection to the cloud, FreeRTOS devices in Greengrass group can continue to communicate with each other over the local network, so your applications continue to run even with intermittent connectivity. FreeRTOS helps keep edge devices secure with security credentials and key management, and it also keeps your data secure with transport layer encryption. We also support a fully integrated firmware update service for FreeRTOS with integrated code signing, and it uses AWS IoT Device Management for those jobs. Next, AWS IoT Device Sdk, otherwise called CSDK, is meant to be used on any operating system, including FreeRTOS, Linux, POSIX class RTOS solutions like QNX, GHSS, VxWorks, and MCU class RTOS solutions like Micrium, Mbed OS, and Zephyr, and facilitates integration with AWS IoT. AWS libraries distributed in the CSDK are the same code as distributed in FreeRTOS. Let's take a look at this data flow. On the bottom, we have edge devices, and at the top, we have the cloud. So starting at the bottom, we have microcontrollers or CPU-based devices interacting with AWS IoT. For instance, a device can sync its state with a shadowed service running in IoT, so that a shadow reference to that device is always there in the cloud. And then they can perform pub-sub communications using MQTT up to an MQTT broker, or just do basic ingest using MQTT. And these devices can also communicate directly with AWS APIs, such as Amazon DynamoDB or Kinesis or S3. Next, there's AWS IoT Device Tester. And this is all about helping your devices that you manufacture get listed on the AWS device catalog. You can authenticate and interoperate with AWS IoT services. You can set up required cloud resources, automate compiling and flashing of test cases on the target device for execution. And then you can get qualified via the device qualification program. And you submit AWS IoT Device Tester results to get listed in the device catalog. Next, we have AWS Robomaker. Robots are the ultimate edge inference and intelligence device. Not only can robots be deployed at the edge, but they're mobile, which enables them to dynamically explore environments and gain data and to act and respond to the data once analyzed and interpreted. With AWS Robomaker, the capabilities of cloud compute are brought to robots of all types, such as autonomous ground vehicles and robotic arms and drones. Robomaker is a cloud service that makes it easy to build, test, and deploy robotics applications. Robotic developers use the CI/CD pipeline capabilities to enhance code development and deployment. AWS best-in-class security services to enhance the safety and security of mission-critical applications of their robots, and the ease of integration with other AWS services to build a robust, scalable foundation for the robot's applications. Robomaker's simulation and multi-robot fleet management capabilities enable companies to manage a diverse fleet of robots with the speed and agility not previously possible. Companies as diverse as iRobot, Woodside, and Bastion are using Robomaker to enhance the capabilities and improve the management of their robots while speeding development and improving quality. AWS Snowball Edge is a self-contained remote computing device ideal for rugged environments. In this scenario we're seeing, specialized industrial or medical equipment is generating machine data that require real-time analysis and decision-making. The data cannot be sent to the cloud for processing with persistent network connectivity. And often, we don't have the environmental requirements or space to run a stack of servers, storage, and networking on site. This makes a great case for Snowball Edge, where customers are able to run key specific workloads on their machine or IoT data and create a powerful little air-gapped IT hub virtually anywhere they need it. And this lets companies take faster action on their business data, but also send information back to AWS for processing. So with Snowball Edge, we have custom Amazon EC2 AMIs. An Amazon machine image you have created can be included in your Snowball Edge when you order the device. The Snowball Edge will be provisioned to include your EC2 AMI before the device is shipped to you. You can therefore develop and test your AMI in the cloud, and then you can run it at the edge. And then there's IoT Greengrass functions. You can run IoT Greengrass functions on the Snowball Edge. So in summary, Snowball Edge is a hardened, secure, and highly performant computing environment outside the data center, suitable for remote and austere locations that have intermittent or no network connectivity. You can collect, analyze, and enable local actions faster. And it's hardware as a service. You have short-term and long-term lease options, and you get full support, upgrade, and device replacement. AWS Outposts brings native AWS services, infrastructure, and operating models to virtually any data center, co-location space, or on-premises facility. Outposts uses the same APIs, tools, hardware, and functionality across on-premises and the cloud to deliver a consistent hybrid experience. Unlike other on-premises hybrid cloud solutions that use different APIs, release cadences, manual updates, and third-party hardware and support, Outposts are fully managed and supported by AWS. Customers have access to the latest hardware and software and do not have to worry about software version control, updating or patching software, or calling multiple vendors for hardware and software support. A variant of AWS Outposts runs VMware Cloud on Outposts to provide customers a common infrastructure platform to run their VMware stack across on-premise and cloud environments. And then there's AWS Wavelength. Wavelength brings AWS services to the edge of the 5G network, minimizing the latency to connect to an application from a mobile device. Application traffic can reach out application servers running in Wavelength without leaving the mobile network. This prevents the latency that would result from multiple hops to the internet on an AWS region and enables customers to take full advantage of the advancements of 5G. Customers can now deliver immersive experiences like game streaming to end users on mobile devices. Robots, cars, and other smart devices can make complex decisions that require more computing power than is available in a small form factor. And this brings AWS closer to end users and devices, unlocking these opportunities. Now, you deploy your application to wavelength zones, which is AWS infrastructure deployments that embed AWS compute and storage services within telecommunication providers' data centers at the edge of the 5G network. Wavelength zones deliver a consistent developer experience across multiple 5G networks across the world, allowing you to build ultra-low latency applications using the same familiar AWS services, APIs, tools, and functionality you already use today. You can deploy portions of your cloud-based applications requiring single-digit millisecond latency to wavelength, and then connect seamlessly to the rest of your application and services running in AWS regions. With AWS Wavelength, you get capacity close to your end users and data, along with AWS benefits such as no capital costs, pay-as-you-go pricing, and the ability to scale up and down on demand. Next, we're going to take a look at connectivity and control services. This suite of services includes AWS IoT Core, AWS IoT Device Management, IoT Device Defender, Amazon Kinesis, and Identity and Access Management, or IAM. Our cloud-based service, AWS IoT Core, forms the backbone for IoT deployments to securely connect all your devices to handle their data at scale. AWS IoT Core allows you to securely connect devices to the AWS cloud and with each other. It allows you to route, process, and act on the data and messages coming from those devices. Reliance Steel and Aluminum Company is one of the largest metal service centers in North America. Many of their machines used to produce goods and materials have been in service for decades. When one fails or breaks down, it has a big impact on their business. They needed a solution, so they connected their industrial machines to collect telemetry data from the different sensors and loggers. The data is ingested by IoT Core and stored in a data lake and used by custom web UI or machine learning services, such as Amazon SageMaker, to perform predictive maintenance. Now, Reliance can drastically reduce the downtime of broken machinery and possibly eliminate the production gap that offline machines can create by adopting a more predictive approach to maintenance. AWS IoT Device Management helps customers register, organize, monitor, and remotely manage their growing fleet of connected devices. You can do things like register and configure devices with a few clicks. You can understand the health and status of device fleets with their logs. You can organize and trigger actions on groups of devices using jobs. And with secure tunneling, you can securely access devices behind restricted firewalls. IoT Device Defender keeps your fleet secure. First, it continuously audits the IoT device resources associated with your devices to make sure they aren't deviating from security best practices and alerts you if something looks like it isn't compliant. For example, one best practice is to not share certificates across devices. But let's say during provisioning of additional devices, someone accidentally reuses a certificate. This will be flagged and you will get an alert. IoT Device Defender comes with 10 security best practices like this that you can select and run as part of an audit, or you can build your own. Now, the second thing IoT Device Defender does is monitor the device fleet for abnormal behavior that might indicate a potential security issue. IoT Device Defender lets you define the expected behavior for different sets of metrics. And then it monitors the device fleet and alerts you if something doesn't look right. For example, IoT Device Defender lets you define what ports should be open on a device, who the device can talk to, and how much data it sends or receives. Then it monitors the device traffic and alerts you if something looks wrong, like traffic from devices to an unauthorized IP address, or traffic spikes in outbound traffic. And all this might indicate that the device is participating in a DDoS attack. And lastly, through its integration with IoT Device Management, IoT Device Defender lets you take corrective action like rebooting a device, updating its firmware, or revoking its permissions via a change policy. Now here's a reference architecture I'll walk you through to show how to provision and manage secure IoT devices. At the top, at step one, we have devices remotely connecting and sending their certificates to IoT Core. At step two, we have IoT Core delivering the message to IoT Device Management. Step three, IoT Device Management registers and saves the certificates. At step four, IoT Device Management pulls the latest firmware for that group of devices from Amazon S3 and sends it to IoT Core. IoT Core sends the firmware as an OTA update to all targeted devices in the group. Now down at step 6 on the bottom, we have actually a camera device here. So a camera device can do two things. It can send telemetry data to IoT Core via MQTT, and IoT Core sends the telemetry data to AWS IoT Analytics. And IoT Events track and perform state transitions for important events that are captured from the camera. IoT Events can receive multiple inputs from sensors within the home. In this case, any alarm triggers an Amazon Simple Notification Service, SNS, notification. And finally, down at the bottom at step 8, we have video data directly going out from the camera to Amazon Kinesis video streams in the cloud. In addition to sending video to Kinesis video streams, the camera uses ML inference on the edge to detect images within the video frames locally. That way, it only sends the important images to the cloud. Way over on step 9, we have Kinesis video streams in a consumer application using a variety of options. In this case, it's a mobile application consuming from the stream, and it's sending images of, in this case, a person to a mobile user. Amazon Kinesis is a family of streaming services. Kinesis video streams that we just mentioned lets you use video, audio, and other time-encoded data to build applications that power robots, smart cities, manufacturing, automation, security monitoring, and machine learning. Kinesis data streams enables you to build custom real-time applications using popular stream processing frameworks of your choice. Kinesis Firehose makes it easy to collect and load data in streams into AWS data stores. And then lastly, Kinesis Analytics makes it easy to process and analyze data streams in real time with SQL. With AWS Identity and Access Management, you can control access to AWS Service APIs and to specific resources. And you can protect the AWS environment by using AWS MFA, a security feature that augments username and password credentials. And you can quickly validate that policies only provide the intended public and cross-account access to resources. And then finally, you can grant federated access to the AWS Management Console and AWS Service APIs using existing identity systems. So thirdly, we're going to take a look now at analytics services. The suite of analytics services is really big, and in these 2 pages, we're just going to look at a few. Specifically to IoT, we have IoT Sitewise, IoT Analytics, IoT Events, AWS IoT Things Graph, and then beyond that, we have Amazon S3, Amazon Athena, RDS, QuickSight, Timestream, and as I mentioned, there are many more. IoT Sitewise lets you connect to industrial equipment, collect, organize, store, and visualize machine data. And with Sitewise Monitor, you can create a fully managed web application for visualizing and interacting with operational data from devices and equipment connected to AWS IoT. It's a custom web application users can access on their laptops, tablets, and phones. With Sitewise Monitor, you can set up and deploy web applications for visibility into industrial machine data in minutes without writing any code. You can automatically discover and visualize data from industrial assets that have already been ingested and modeled with AWS IoT Sitewise. You can easily share access to industrial data with any team in your organization to accelerate insights. And web applications created through Sitewise Monitor support single sign-on through integration with on-premise Active Directory and SAML providers such as Azure Active Directory. Here's a quick demo. You see a process engineer configuring a dashboard in Sitewise Monitor here. The process engineer drags and drops the metrics and properties their users will be interested in. The visualization type can easily be changed, i.e., for example, here we switch from a line to a bar chart. Once you save the dashboard, you're instantly set up and viewing live data and computed metrics. At any time, you can select a period of time you want to dig into, and the dashboard will update all graphs to reflect that time range. Bayer Crop Science provides products and services to enable sustainable agriculture for farmers. Bayer lacked real-time data collection and analysis needed to catch issues with equipment to help with routing plans for subsequent runs. They also needed to give farmers real-time access to their collected traits so they can complete their QA and QC steps in a timely manner. Using AWS IoT Core and IoT Sitewise, Bayer manages the collection, processing, and analysis of seed growing data. Data analysts use the data collection platform to access data on their mobile devices and dashboards. It captures multiple terabytes of data from seed transportation, planting, and growing research fields across the globe. And now Bayer can get seed data to analysts in a few minutes instead of a few days. It also helps farmers gain better visibility into field conditions and provides a robust edge processing and analytics framework to ensure corrective actions in the field, meaning customer SLAs for quality control. IoT Analytics is a fully managed analytics service to easily analyze IoT data. First, you define an IoT analytics channel and select the data you want to collect so you only store and analyze the data of interest, such as sensor temperature. IoT Analytics automatically captures and stores the message timestamp and device ID with data from the device, so it's easy to perform time series analytics. IoT Analytics can also enrich the device data with IoT-specific metadata, such as device type and location from the AWS IoT Device Registry and other public data sources. Once the channel is set up, you configure IoT Analytics Pipelines to process your data. IoT Analytics Pipelines support transformations like Celsius to Fahrenheit conversion, conditional statements, message filtering, and message enrichment using external data sources and AWS Lambda functions. After processing the data in the pipeline, IoT Analytics stores it in an IoT-optimized data store for analysis. You can store the process data and the raw data in case you want to go back later and perform different processing on the raw data. Once your data is stored in IoT Analytics, you can query the data using built-in IoT Analytics SQL query engine to answer specific business questions. IoT Analytics also supports more sophisticated analytics via Jupyter notebooks, like statistical inference, for example. So you can get business insights such as understanding the performance of devices or predicting device failures using time series analysis. And last, it's easy to build visualizations and dashboards and get business insights quickly from your IoT Analytics using Amazon QuickSight. With AWS IoT Events, you have a managed service that continuously monitors data from equipment to identify their state, detect changes, and trigger the appropriate responses when changes occur. You build a simple logic to evaluate incoming telemetry. You detect events from data across thousands of sensors and other sources, and it triggers responses to optimize operations. AWS IoT Things Graph helps you rapidly build IoT applications as workflows. You use models to represent devices or web services. You use drag and drop visual UI to compose your application workflows. and you deploy and monitor in the cloud or at the edge. Amazon S3 is something you're probably all familiar with, but to reiterate what it can do for you in edge computing and IoT, it helps you with backup, restore, and archive, with disaster recovery, with building data lakes and big data analytics, and cloud-native application data. Amazon Athena is for interactive analysis, making it easy to analyze data directly in S3 and Glacier using standard SQL queries. Athena is serverless, so there's no infrastructure or setup to manage. And companies can start querying data instantly, getting results in seconds and paying only for the queries they run. Athena is easy to use. You simply point to your data in Amazon S3, define the schema, and start querying using standard SQL. Most results are delivered within seconds. With Athena, there's no need for complex ETL jobs to prepare your data for analysis. This makes it easy for anyone with SQL skills to quickly analyze large-scale data sets. Now, Athena integrates with AWS Glue Data Catalog, allowing you to create a metadata repository across various services, crawl data sources to discover schemas, and populate your catalog with new and modified table and partition definitions, and maintain schema versioning. You can also use Glue's fully managed ETL capabilities to transform data or convert it into columnar formats to optimize costs and improve query performance. Amazon RDS is a fully managed relational database service that you can use to run your choice of database engines, including open source engines as well as Oracle and SQL Server. Amazon RDS improves database scale and performance and automates time-consuming administration tasks, such as hardware provisioning, database setup, patching, and backups. Amazon QuickSight is a cloud-native BI solution. It's serverless with no servers or software to manage. You can start with tens of users and scale up to tens of thousands of users. And furthermore, it's the only solution with pay-as-you-go pricing for readers, for as low as 30 cents a session and capped at $5 a month. Amazon Timestream is a fast, scalable, fully managed time series database service for IoT and operational applications that makes it easy to store and analyze trillions of events per day at 1/10 the cost of relational databases. It's driven by the rise of IoT devices, IT systems, and smart industrial machines. Time series data that measures how things change over time, is one of the fastest growing data types. Time series data has specific characteristics, such as typically arriving in time order. Data is append only, and queries are always over a time interval. While relational databases can store this data, they're inefficient at processing the data as they lack the optimization, such as storing and retrieving data by time intervals. Timestream is a purpose-built time series database that efficiently stores and processes this data at time intervals. With Timestreams, you can easily store and analyze log data for DevOps, sensor data for IoT applications, and industrial telemetry for equipment maintenance. As your data grows over time, Timestream's adaptive query processing engine understands its location and format, making your data simpler and faster to analyze. Timestream also automates rollups, retention, tiering, and compression of data so you can manage your data at the lowest possible cost. Timestream is serverless, so there are no servers to manage, and it manages time-consuming tasks such as server provisioning, software patching, setup, configuration, or data retention and tiering, freeing you to focus on building your applications. The next category we'll look at now is AI and ML. AWS makes AI ML easier than ever for customers. We see the machine learning stack having three key layers. At the bottom are the frameworks and infrastructure for those comfortable building and maintaining their own ML platform and underlying infrastructure. In the middle layer are the machine learning services that make it easy for machine learning developers and data scientists to build, train, and deploy machine learning models in a single click with Amazon SageMaker. In addition to the IDE, all Amazon SageMaker features are available through APIs. And then at the top, we have the API-based AI services that allow all developers to use pre-trained and auto-trained models to add intelligence to any application without machine learning expertise. Amazon SageMaker is a fully managed service that removes the heavy lifting from each step of the machine learning process. Since launch, AWS has regularly added new capabilities to Amazon SageMaker, with more than 50 new capabilities delivered over the past 12 months. These capabilities have helped many more developers build custom machine learning models. But just as barriers to machine learning adoption have been removed by SageMaker, customer desire to utilize more machine learning at scale has only increased. Amazon SageMaker makes a lot of the steps required to develop great machine learning models much easier. Amazon SageMaker brings lots of tools together through an IDE so you can test, debug, deploy, monitor, and profile all within a single environment. And here's a predictive maintenance reference architecture I'll walk us through now. At step 1, we configure IoT Greengrass using Greengrass connectors to communicate with factory machines. At step 2, we configure rules within AWS IoT Core to trigger events based on MQTT topics for the factory machines. At step 3, we create a Kinesis Firehose delivery stream to store the factory machine's data on the data lake in Amazon S3. At step 4, you build your predictive maintenance machine learning model with Amazon SageMaker. At step 5, you deploy your machine learning model onto AWS IoT Greengrass Edge Gateway. At step 6, build your data queries in Amazon Athena against your AWS Glue data catalog of the data lake on S3. At step 7, visualize your analysis using QuickSight on the Amazon Athena data source. In step 8, create an anomaly detection application in Amazon Kinesis Data Analytics. And finally, at step 9, configure AWS Lambda as an output of Kinesis Data Analytics application to send anomaly detection notifications to an Amazon SNS topic. Vantage Power designs and manufactures technologies that connect and electrify powertrains in heavy-duty vehicles. Vantage Power wanted to create a way to closely monitor their lithium-ion battery systems to help customers detect cell-level defects early and mitigate issues. So Vantage Power created a telemetry system, VP Vision, that uses AWS IoT Core, IoT Greengrass, and IoT Analytics to bring AWS Cloud to connected vehicles. They process hundreds of thousands of data points per minute to derive insights and predictive analytics models that can be distributed to the vehicles to take preventive action in real time. And now Vantage Power can provide safety and compliance controls to individual vehicles and reduce costs through remote diagnostics and edge computing. With AWS IoT, they can detect cell-level defects of a lithium-ion battery, which can cost over $50,000 per bus. And now we're going to look at how AWS Integrated Security wraps all of these things we've been talking about. Security at AWS is our top priority. Enterprises who move to the AWS cloud achieve a higher security posture than in their legacy environments with greater agility. As an AWS customer, regardless of your size or investment, you inherit all the benefits of our experience, tested against the strictest of third-party assurance frameworks. Security at AWS starts with our core infrastructure. Our global infrastructure is custom built for the cloud and designed to meet the most stringent security requirements in the world. As an AWS customer, regardless of your size or investment, you inherit all the benefits of our experience, tested against the strictest of third-party assurance frameworks. And secondly, with AWS, You control where your data is stored, who can access it, and what resources your organization is consuming at any given moment. Reduce risk as you scale by using our security automation and activity monitoring services to detect suspicious security events like configuration changes across your ecosystem. And thirdly, AWS is vigilant about your privacy. Because our customers care deeply about data security, we have a world-class team of security experts monitoring our systems 24/7 to protect your content. With AWS, you can build on the most secure global infrastructure, knowing you always own your data, including the ability to encrypt it, move it, and manage retention. Fourthly, automation helps reduce the amount of noise and manual work your security engineers have to pay attention to, so they can focus their expertise where it really matters for your business. And fifthly, extend the benefits of AWS by using security technology and consuming services from familiar solution providers you already know and trust. These solutions work together to help you secure your data in ways not possible on premises. The stack we've just looked at is complex, and customers have diverse use cases. There is no one-size-fits-all architecture for IoT. At reInvent last year, we launched the APN Edge to Outcome Partner Value Chain to address the complexities of IoT. These are partners spanning the edge, cloud, and analytics spaces. This community helps you by simplifying solution builds with AWS IT, with deployment, and by reducing time to value for your solution. APN Partners' expertise in IoT spans silicon, edge, OEM hardware, edge software, connectivity, and domain-specific applications from ISVs and system integrators. This edge-to-outcome partner community approach helps to ensure three things: coverage, ease of deployment, and differentiation. The AWS Partner Device Catalog helps you discover qualified hardware that works with AWS services, so you never have to worry if your selected hardware will work with AWS IoT. You can find hardware that works with AWS, including development kits and embedded systems to build new devices, as well as off-the-shelf devices such as gateways, edge servers, sensors, and cameras for immediate IoT product integration. The choice of AWS embedded hardware from our curated catalog devices from APN partners can help make the rollout of your IoT projects easier. AWS devices listed in the AWS Partner Device Catalog are also available for purchase from our partners, so you get started quickly. You can filter by device type, industry, region, and more to help you quickly find the right hardware for your requirements. With hundreds of devices and more being qualified all the time, the device catalog helps you build and deliver successful IoT solutions. For your reference, we have 48 IoT customer profiles who span manufacturing, oil and gas, transportation, utilities, and industrial products. So now for you. The question is, what edge services should I use? That's the question we asked at the beginning. So here's some questions for you to consider to help you with your decision. What are your latency objectives? And can they be met with AWS regions? Should you optimize your application architecture for latency? What AWS services do you really need at the edge? Do you need everything AWS IoT offers? If AWS Outposts, does your environment meet the requirements? If AWS Wavelength, what carriers and locations are required? And with that, I thank you for listening in today. And we're going to spend the remaining time that we have continuing to answer your questions.